Okay, we got to move right on into pyramids and cones. So right underneath where we stopped the last one, you'll see surface area of pyramids and cones. More vocabulary here, and this has an added twist, an added piece that's going to kind of throw us for a little bit of a loop. So in a pyramid, so all of the sides this time are triangles instead of the sides being rectangles. Okay, so that's going to change our formula a little bit. The other thing is, so S stands for the side length. So this is the side of the base, side of the base, side of the base, side of the base here. So that square on the bottom is your base, and so this is a square pyramid because they all come up to one point. Okay, so if it's a circle on the bottom and they all come up to a point, that's a cone. If it's a hexagon on the bottom, it's a hexagonal pyramid. Okay, so we're going to do surface area of pyramids and cones. So the formula is, this time, again, it's lateral area plus base. But for both of these, when you do the lateral area, because they're triangles, there's going to be a 1/2. Okay, because it's a triangle, so it's 1/2 base times height. Now, this, what you're going to see here, you're going to see this cursive L. That L has a special name. It is called the slant height. We obviously can't say S for slant height because of the fact that we already have an S here, so that's why it's a cursive L. Okay, and that is this length here. Now what that length is that is the height of one of the side triangles. Okay, so when you're finding the lateral area, you have to use slant height because that is the height of the triangles on the side. And remember, lateral area is the area of the side pieces. So for a pyramid, instead of perimeter times height, it's going to be 1/2 because they're triangles, still perimeter, times slant height instead of height. Now height still exists within a pyramid. It's still the top to bottom distance in the shape, but we don't use that because that's not the height of the sides, which is the lateral area. Plus, and then this doesn't have two bases. It only has one base. It's only got one square on the bottom, so that is the area of the base. Now this one happens to be a square, so it would be S times S, or S squared. Okay. You're also going to find out that there is a relationship between slant height and height. It makes a right triangle, and sometimes you're going to be given height and you're going to have to find slant height. Okay, so we're going to work on that throughout our examples today. Same thing over here. You're going to see that in the cone, the height goes through the middle of the cone. The slant height is along the side, the slanted side, and then radius would be right here. So with the cone, if I gave you height, you'd have to use the Pythagorean theorem to find the slant height. Okay, so the formula for the cone, and again, these are all on your formula sheet, is 1/2 perimeter slant height plus 1 base area. Now what happens when you put 1/2 and perimeter together with a cone is you get half of 2 pi r. So the half and the 2 cancel out, and you'll notice that on the formula it just says pi r L plus 1 base area, which is pi r squared. So the formulas are a little, it's simplified, but it still comes from the same place. So here's the formula for a pyramid. Any kind of pyramid that has a square on the bottom or a hexagon on the bottom, this is going to be the formula. If it has a circle on the bottom, and if it's a cone, it's going to be this formula. So I'll clean that formula up for you. Surface area equals pi times radius times slant height plus pi radius squared. Okay, and I would always put the formula, and if you put the formula and then put numbers into the formula, you'll at least get some credit. So whatever you do, do not leave a question blank. Start with the formula and put numbers into the formula. Okay, let's do some examples. Okay, so we're going to do these 3 examples here, and so I'll zoom in as we're working so that we can actually see the picture a little bit better. Okay, so you see a square along the bottom, so this is a square pyramid. 7 is our slant height. So because this is a pyramid and not a cone, there's pyramid formula, cone formula, that's it. There's only 2. So surface area equals 1/2 perimeter of the base times slant height plus 1 area of the base. Now again, I'll use my orange again, just like I did in the first video, to mark that height that we're going to be using along the side, which is called slant height. Okay, and this perimeter is the perimeter of the base. All right, here we go, 1/2. The perimeter is going to be 8 plus 8 plus 8 plus 8. Now, obviously, you don't have to write that all out if you just want to put what 8 plus 8 plus 8 plus 8 is. I just don't want anybody getting confused where I'm getting my number from. And I'm going to multiply that times, so I've done 1/2. This is the perimeter of the base. Now I'm going to throw in my slant height. Slant height, again, is this 7 that's slanted along the side of the triangle. So that's going to be 7. Plus, this time it's just 1 base. There will not be a 2 after this because there's not 2 bases. There's just 1 base, and it's the area of that base. This happens to be a rectangle, which is 8 times 8. Okay, now I'm ready to just throw all this into a calculator. Okay, so this is really the work that has to be there, and then from there, putting it into the calculator. Okay, so 8 times 8 plus 8 plus 8 plus 8 is 32. So 1/2 times 32 times 7. Okay, or you could type it in just as you see it here, and you can even do this in Desmos. There's parentheses, so 0.5 for the half, parentheses, type it in just the way it looks, okay, plus, and then 8 times 8, you can put parentheses if you want, and get your answer, which is 176. Okay, we're still doing area, surface area, so it's 176 yards squared. All right. Okay, this is a cone, so let's write the cone formula for surface area. How do I know which one is the cone? It's the one with the pi in it. Okay, so it's pi r L. It has slant height. There is a slant height in this picture. Plus pi r squared. Now let's just take a second to talk about if I was given this number here for height, and I was trying to find slant height. So if you're given this number height, you will not be using that number into the problem here. The slant height is this number. So if you're not given that number in the problem, you are going to have to find it using Pythagorean theorem. And it would be this number squared plus 10 squared equals L squared. And you'd have to find that number. Now we don't have to do that on this one because it's already there for us, but just in case you see a problem like that on the practice, you'll know how to find that number. So my radius here is 10. So when I plug these into the formula, it's going to be pi times 10 times, let's throw in our slant height, 13, plus pi 10 squared. Okay, and if you want to simplify this, you can. So we're going to take 10 times 13, and that's going to be 130 pi, plus 10 squared is 100 pi, and then we can add them together. Since they both have pi's, put those two together. There's no label on this one, so I'm not even going to put units squared. If I don't put a label on it, you don't need to worry about a label for the answer. Okay, last one here. This one actually is the tricky one. It doesn't have a slant height marked in the picture, so we're going to have to find it. And it's pretty much the most complicated picture that you're going to see as well, because we have a 1, 2, 3, 4, 5, 6, 7, 8. So we have an octagon along the bottom. Now, for that part, do not worry about that part, because you do not need to do 360 divided by 8 to find the angle measure and then take the angle measure times. You don't need to do that because you're already given the side length and you're already given the apothem. Okay, so you won't have to do any of that extra stuff. What you will have to do is when you go to write slant height down in the problem, we are going to have to actually find slant height. Slant height is not in this picture currently. So I'm going to start by just writing the formula. Sometimes we get overwhelmed with the problem and we don't know where to start. Always start with just writing down the formula, and then we'll fill in what we know. Okay, so the one thing I do know is perimeter of the base. Okay, let's fill that in. The perimeter of the base is 2 plus 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 2. So we have 2 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8, 2, so that's 16. Now we're looking for the slant height. So this number that I put here next, I don't have in the picture. So we're going to take a time out really fast, and we're going to find that slant height. So that slant height right here, the apothem to the height, and connect those to make a right triangle. That is your slant height. And this was a super nice setup for you because, I'll put slant height on this side, if you have a 3 for one side and a 4 for the other side, what will be your hypotenuse? And the slant height will always be the hypotenuse. Okay, so slant height will always be your c squared. So a squared, b squared, c squared. Slant height will always be your c squared. But if you know that one of the sides is 3, the other side is 4, the hypotenuse is always going to be 5. Okay, so if you went through this process, 3 squared is 9 plus 16, which is 25. The square root of 25 is 5. So my slant height is 5. So we actually had to find the slant height on this one because it didn't give it to us. Plus, now I need to do the area of the base. So the base area for my octagon is half the side length, which is 2, half the side length, times the apothem, times the number of sides. So half of my side length is 1, times my apothem, which is 3, times my number of sides, which is 8. Okay, so if I wanted to clean this up a little bit, remember here we have half, this is 16. So half of 16 times 5 plus my 1 times 3 times 8. All right, now we're ready to type this into a calculator. So 1/2 or 0.5 times 16 times 5 plus 1 times 3 times 8 is 64. 64 centimeters squared.